Color by numbers. Image representation. For this activity, a group considering 5 kids per team is taken for example. Step 1. Give a sheet of paper like shown in figure 1. Step 2. Let all 5 of them draw something over the sheet, example shown in figure 2. Make sure the kids shade the boxes properly. Don't allow half shaded pixel as each pixel should be a perfect square. Step 3. Collect the sheets from all teams with the team names noted. Now give a new sheet that is blank as shown in figure 1. Step 4. Let them formulate the idea to interpret the picture only with numbers. Add a rule like only numbers should be used and no alphabets. Given a sheet that is drawn, they should be able to tell the location of shaded portion only with numbers. This could be explained with an example. Give numbers to the rows and columns of answer template. Consider row 1 of figure 2. Notice that only row 1 and column 2 shaded, then row 1 and column 4 are shaded. The same way for row 3, notice that row 3 is shaded from column 2 to column 4. There can be an optimization algorithm like a null number, in our case 0, which is not used, as the filling number to indicate an array of boxes to be shaded, thus reducing bits. Wonder how it reduces bits? See, if using normal algorithm of 2 numbers per box, then at totally 5 boxes per row, which makes the total number of bits to 10. To reduce number of bits, we can have a filling number 0. So now for first box we use 2 bits, and last box we use 2 bits, and in between we use 1 bit, which is 0. So totally the number of bits is 5, and there is 50% reduction in the number of bits to represent array of shaded bits. Similarly, something new can be discovered with the help of secondary volunteers. Make sure that kids should come up with idea and volunteers should be like oil to the fire. Step 5. After formulation of ideas to encode and decode, separate the 5-member team into 3 subgroups. 2 will stand on the right side of the room, and 2 on the left side, and 1 on the middle of the room. Step 6. Give the swapped answer sheets with pics to kids on the right side, then give the blank question sheet as shown in figure 1 to the kids on the left side. Start timer, give 10 minutes. The kid in the middle should run to and from with numbers from right side of their team to the left side. The process continues till 10 minutes or till completion of picture replication. After the completion of 10 minutes, let's compare the question and answer sheets. Let them understand that there were some errors. Give marks to the teams that did the activity honestly and accurately. To correct the errors found on transmitting message from one side to another, there is a technique that detects the bit errors. Start the activity like it's a magic, as this activity will surprise kids. Card flip magic, error detection and correction. For this activity, we need 2 volunteers. One will draw on the board and other will stay out of the classroom. The volunteer goes out even before starting this activity, referring to kids that he is a magician, and will find the errors in the messages. The volunteer in classroom will draw something like shown. Only the shaded and unshaded boxes, and don't write number on rows and columns, as it is just for explanation. Notice that the shaded boxes count row wise and column wise. All are even, either 2 or 4. Call a kid from group and request to rub one box. Then call the volunteer standing outside the room. The volunteer will easily find the box that was rubbed, as the corresponding row and column of the erased box will have an odd number instead of even. The same is applicable if all the rows and columns are odd. This will surprise kids initially, and we have to do it 2 or 3 times to make them feel like we are not cheating them. Finally, reveal the secret. I am sure they would enjoy this. Note that this technique will work only for 1 bit error. If we rub more than 1 bit, then the algorithm fails. To work for more than 1 bit, there are many other algorithms to do that, which we will not study now. Fax machine encoding scheme. We have seen encoding and decoding with error correction and detection. But how does real fax machine does it? We will see it now. Remember the pattern WB 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 dot dot dot. So W means white and B means black. Check the first row of the pic shown. We have one white box followed by 3 black boxes and then one white box. So given 1, 3, 1. The total count adding 1 plus 3 plus 1 is 5, which means the first row is completed. Second row starts with 4 white box then 1 black box. So given 4, 1. If you add them, it makes 5. Third row again 1 white followed by 4 black. But now next row, that is fourth row, is little different. It starts with black, but according to our pattern it should be white first, as the pattern is WB WB and so on. So we have no other go but to put 0 white first, then followed by 1 black, then 3 white, then 1 black. So given 0, 1, 3, 1. Thus adding them, 0 plus 1 plus 3 plus 1 is 5. So in this way the data is transmitted serially and we are highly reducing the number of bits transmitted. This is how a real fax machine works. Treasure hunt activity. Treasure hunt game is used to teach kids the importance of flowchart. Start the game as a surprise without any pre-discussion. Step 1. Give the template paper to each team that has all islands in one sheet. Let each volunteer have one island and stand on corner of the rooms. It will be great if this activity is done outdoor, if possible. Step 3. Each team target is to reach Treasure Island. For that, each team will act as a pirate crew that finds ships on each island and chooses the best ship to reach Treasure Island. Step 4. All teams should start at Shipwreck Bay, which is considered as harbor, and the kids can ask either for ship A or ship B. Volunteer then directs the team to islands. Make sure the answers to A and B ships are not visible to kids. Step 5. This process continues as there will be another A and B ships in each island and each team can ask only one of A or B per turn. Step 6. This will go on for some time and ultimately some team might end up Treasure Island. Here, volunteers need to be strict that kids should mark the route they have come across, as there could be some cheating possible. Give 30 to 45 minutes for the game and discuss the answer sheet, which is shown in next slide. As per the answer sheet, this looks more like a route from Shipwreck Bay to Treasure Island, where there are many loops. For example, if from Shipwreck Bay, if a team asks 2 consecutive A ships, then they will end up looping between Pirates Island and Shipwreck Bay. Let's relate it to real-time example. Consider boiling water. Let's make a metaphor like Shipwreck Bay is pan with water boiling and Pirates Island is thermometer that measures temperature. Consider A as boiled water and B as stop boiling. So if the temperature is more than 100 degree, then stop boiling, else continue boiling. In the same way, we have to make kids understand that planning a project is more important before executing it. Flowchart is a pictorial representation of a program that does something. It is usually designed before starting a project to make sure all the requirements are covered. This helps in finding problems in process that any project does and also reduces future problems by perfecting design. The above shown are some blocks that will be used to draw flowchart. Each block has its own unique function as shown and will be used dedicatedly for the type of function that is needed for the process flow. A small example to teach flowchart. Scooby-Dooby-Doo. Now let's cross the street. Move the blocks of flowchart and find the correct procedure to cross the road. Let kids come up with flowchart for coffee or tea or washing machine or something that interests them.